Cosmic filaments weave through the universe and form mysterious connections. Now, for the first time, a gigantic thread connecting two galaxies has been discovered in the young universe. This cosmic highway could completely change our understanding of the structure of the universe and bring us much closer to the blueprint. What role do these gigantic structures really play? Are they just empty gas bridges, or the hidden veins through which matter and perhaps even life in the universe are distributed? Scientists have come across a massive structure in their search for the hidden architecture of the universe. Astronomers from Chile discovered a single cosmic thread that is 850,000 light-years long and most likely belongs to a larger structure that extends over an estimated 3 million light-years. The sensational discovery was made using a combination of the latest telescopic technologies. Researchers combined the Very Large Telescope in Chile with the special capabilities of the multi-unit spectroscopic explorer to search for clues in the depths of the cosmos. The multi-unit spectroscopic explorer, or MUSE for short, is a state-of-the-art instrument that combines spectroscopy and imaging to analyze light from different areas of a celestial object simultaneously. This allows the instrument to provide detailed 3D data of galaxies, nebulae, and cosmic structures. The images are ideal for studying the cosmic web and reveal another dimension of the hidden blueprint of the universe. Cosmic thread discovered in Lyman Alpha Nebula. Imagine a gigantic glowing gas cloud about 11.5 billion light-years away from Earth. Here, close to the temporal edge of the universe, an enormous thread wafts through the cosmos. The mysterious structure spans at least 850,000 light-years and connects two of the universe's early galaxies. Cosmic threads, also known as filaments, are the weavers of the universe. The structures of the filaments form a gigantic network in the depths of the universe, which serves as a supply structure and framework. Gas flows through the filaments and galaxies increasingly form at the junctions. Scientists who use the Very Large Telescope and MUSE to study 7 galaxies in the area in more detail came across the breathtaking structure rather by accident. A thread that is part of a structure several million light-years long and existed at a time when the universe may have been young provides a clue to one of the first threads of the universe. Are we looking at one of God's threads here? Scientists often reject such comparisons, but the discovery has inspired awe even among the most hardened researchers. The composition of the web indicates the thread's central role in cosmic development. It's possible that this filament structure was one of the first to serve as a birthplace for galaxies. The enormous filaments are more than just connecting lines or basic patterns of cosmic structures. Filaments collect the gas necessary for star formation, bundle it in places, and thus promote the formation of star clusters and eventually entire galaxies at certain locations. The Lyman Alpha Nebula, in the constellation Aquarius, is connected to the quasar Q1317-0507 by the thread. The enormous connecting line revealed to scientists a level of metallicity that is 10,000 times lower than it is today. This would indicate an early cosmic structure. In the early days of the universe, the metals in the universe were much lighter than they are today. In the young universe, light elements such as hydrogen, helium, and lithium were the predominant building blocks. Only later did other gases such as oxygen or carbon join them. Are we closer to decoding the blueprint? We live in an exciting era of exploring the universe. We may be closer than ever before to finally decoding the universe. Our technological possibilities have increased dramatically in the last 10 years alone. Currently, science is making quantum leaps in the further development of telescopes and spectroscopy. New super telescopes are launched almost every year, and we are still a long way from the end of these developments. The combination of the Very Large Telescope with the multi-unit explorer is just another stroke of genius by astronomers. With the help of the new facility, plastic 3D scans of the universe are possible for the first time. This reveals fascinating hidden structures. Despite these improvements, examining the details in the deep layers is still a difficult task. Detecting intergalactic gas is a challenge, and at the same time, it's important that researchers identify the gas correctly. You have to imagine that researchers read the gas traces like forensic experts do with fingerprints. The distribution, structure, and type of gas helps researchers to reconstruct the conditions in the early universe. Small mistakes can have big consequences. Gases can be detected indirectly over distances of several billion light years. When the gas absorbs the light of bright background sources, modern spectrometers can create perfect analyses. Each gas scatters the light in a unique way, and the fine sensors of the Very Large Telescope and NEWS can read the traces almost perfectly. If there is no bright background source, however, this is hardly possible. The work of the astronomers is truly like cosmic detective work. To the regret of the researchers, the observation results so far don't allow any conclusions to be drawn about the exact distribution of the gas within the cosmic filaments. Despite their gigantic size, cosmic filaments remain only weakly luminous and elusive structures in the depths of the universe. What are filaments and why are they important? The cosmic threads are sometimes compared to the human nervous system. Filaments probably also function as supply channels, as organizing structures, and possibly they are responsible for the distribution of other important signals. The first filaments were discovered in the 19th century, when scientists observed the remnants of a supernova. The glow of the stellar explosion also revealed the presence of a reticular structure. Filaments were not only present in the early days of the universe, they still exist today, and by and large, still perform the same function as they did 11.5 billion years ago. However, they have probably changed in the course of the evolution of the universe. It's currently an exciting question as to whether there are other structures underlying the filaments. Researchers are curious to know whether the most modern scans of the depths of the universe will also reveal something about dark matter. Dark matter is considered to be the actual building block of the universe. However, the catch is that we cannot even see it with the best telescopes. Dark matter is thought to make up the majority of the universe, but its existence has never been directly proven. We're even at a crossroads where it would be important to finally be able to prove that this matter really exists. If not, then our current cosmology could be decisively flawed. New technologies are constantly reducing the limits of observation, and the latest telescopes are providing us with ever clearer images and deeper space scans. Despite the advances, more than 90% of the structures in the universe still remain invisible, and you can imagine that researchers are truly searching for a glimmer in the darkness to answer our questions about the why, where, and where to. Computer-based models of the universe and quantum computers are expected to deliver revolutionary insights over the next 20 years. Researchers hope that AI-based technologies can fill the gaps in our cosmology. On top of that, these new possibilities could finally show us how to prove the existence of dark matter and dark energy after all. Cosmic strings and string theory? Does the idea of cosmic filaments also sound something like string theory to you? The question does indeed arise as to whether there is a connection between the theory of cosmic strings and string theory. For those of you who are not familiar with string theory, this alternative explanation of our universe proposes that the basic building blocks of the universe are not particles, but long vibrating strings. These strings weave a basic network of matter and create the appearance of particles by flashing into particles when they oscillate periodically. String theory proposes that our universe is made up of 10 to 12 dimensions, and its scientific certainty is doubted precisely for this reason. We currently only have access to 4 of these dimensions, leaving the remaining 6 to 8 purely theoretical. String theory challenges us to accept a great many unknowns. However, it's currently the only theory that can unify quantum physics with the world of visible matter. At first glance, strings as building blocks of matter have nothing to do with cosmic filaments. Cosmic filaments are structures several billion light years long and considerably wider. The strings of string theory, on the other hand, are in the subatomic realm. They would not be visible even with the world's best telescopes and microscopes. An atom is not really visible, and a string would be 1,000 times smaller than an atom. However, recent work in string theory has revealed that tiny strings in the subatomic range can lead to the formation of gigantic cosmic strings in the extension. This would correspond a bit to the assumption that the structures on a small scale are mirrored in the structures of the large space. This principle is found more often in the universe. When we form spheres, spirals, and rotational movements, we see elementary structures that repeat themselves. The same could be true for thread-like forms. For example, strings. Interesting objects of string theory in highly extended D-branes. These so-called D-strings could resemble cosmic strings in their properties. The strings from string theory could theoretically radiate gravitational waves, which are currently being observed by facilities such as LIGO in the USA. The detectors, which are several kilometers long and located in the US state of Washington and in Louisiana, capture the finest cosmic waves. These waves are also a fingerprint of the processes in the universe. By studying the waves, researchers hope to gain further insights into the processes and structures of the universe. In 2006, researchers even announced the discovery of cosmic cracks. The signals from giant K-strings caused a stir, and these cracks were interpreted in the continuation of the investigation as traces of the Big Bang. The theory is that the rapid expansion of the universe immediately after the Big Bang left the finest hairline cracks in the cosmic structure, just as ice can develop fine cracks when exposed to water. The cracks are probably the result of areas with very different physical properties. Cosmologists believe that originally about 80% of the cracks were infinitely long. In the further evolution of the universe, the structures formed huge loops, which later became something like traffic junctions in the universe. Since then, the universe has expanded considerably, and most of the infinitely long filaments have split into countless finer filaments and structures. The discovery of the extremely long filament between the two galaxies could now be a clue that connects the theories of the cracks after the Big Bang and the structuring of the early universe. Threads that originate from the birth of the universe could help to better understand the properties of the primeval matter. They could help to explain how galaxies were formed and where the most energetic particles of cosmic radiation come from. Click the subscribe button now. New videos are coming all the time.